City Below the City, Urban Planning of the Future. And I have here the logo of Digital Underground, which was mentioned from the city of Singapore. My name, as Maurice mentioned, is Antonia Cornaro. I'm an urban planner by background. I work for Amberg Engineering, an underground design firm based in Zurich, but active worldwide. And I'm the co-chair of ITACUS. ITACUS is the ITA Committee on Underground Space. And we work worldwide on sharing knowledge of space underground. I have also co-authored a book which is called Underground Spaces Unveiled, Planning and Creating the Cities of the Future. We have a dedicated homepage on thinkdeep.net with my co-author Han Admiraal, who is an engineer from Holland. And why I'm mentioning it is because it's really about unveiling the potential of the underground to the wider community, to anyone interested in our future cities development. So my hypothesis is we need to plan the space in our cities more carefully than ever. A growing demand on housing, office space, infrastructure, and open space is competing for the subsurface and urban surface areas. And to gain better insight, or should I say geo-insight, a coordinated planning approach incorporating the subsurface is required. And this requires a shift from thinking in area, in volume. I will briefly talk about challenges our cities are facing, the need to visualize the subsurface, which is really very much the topic of today's event. Data, data, data. Where do we get it? How do we process it? How do we use it? And why do we need a new planning methodology for urban planning in general, including the subsurface? A bit on work in progress and some conclusions. So the use of underground space, be it contemporary or future infrastructures, require space. And we are rapidly running out of surface space. Same time, we really want to and need to keep our cities livable. We cannot use every last bit of public space for new infrastructures. And underground space use offers a lot of advantages in that aspect. So what are these advantages? It is much easier to create unhindered and direct connections in the subsurface. We don't have any surface impact on communities when we construct and house infrastructures underground. Well, let me put it that way, maybe while construction, but not once they are in place. We have no environmental impact on the surface. We have rapid development of a new layer of supplemental infrastructure possible, and we are allowing for new combinations that serve the modern needs of the city, be it data transmission, be it telecom, be it cargo movement, whatnot. So how do we achieve this urban underground future that we are setting out to have in the future? I want to briefly take you to a book I read, which is called Flatland, and it's a romance of many dimensions. It was written last century by Edwin A. Abbott, and he really, it's a satirical novel, and he basically tries us believe we are in a two-dimensional world. And he goes into saying, well, no dimension is point land, one dimension is line land, two dimensions are flat land, and three dimensions are space land. And I want to take you from flat land, into space land. So together with my co-author Han, we argue we really need a volumetric planning of the subsurface. So it's no longer enough to see and live the world in 2D. Our high-density cities grow upward and downward, and the flatland approach only considers the horizontal no longer suffices. All of us in this business, but especially architects, engineers, geographers, to name a few, move towards this volumetric approach. We need a better differentiation between height and depth. And underground space planning calls for a volumetric approach, which includes thinking in layers. We need to move from flatland to spaceland. So a 3D visualization, as opposed to the traditional 2D approach of the urban fabric, is needed. And traditionally, we have planned our cities in 2D. So we want to really push this to the 3D volumetric approach. Once more back to Abbott and his flatland, where he describes what it would be like to live in a 2D world. This existing paradigm, which consists of extending surface planning practice downwards, isn't working. The overarching reason for this is that underground space calls for a volumetric approach. So the world Abbott describes is a far cry from how we actually observe and interact in our physical world, which is three-dimensional. And in the same way, we propose that planning of the subsurface is radically different from how we have been planning our cities up to now. So the role of geology in all this is, of course, a big one. On the surface, buildings are surrounded by air. Below the surface, buildings are contained inside the earth. They become part of the subterranean. And the planning approach must be one where the geology is the single most important factor. So here we have an example of a yaodong. Those are traditional sunken habitations in the north of China, which is a very windy plateau, the Loess Plateau. But there it's also very easy to dig out these habitations. And they at the same time protect the population or habitants from the harsh, windy climate. So the volumetric planning of the subsurface really needs to be a multidimensional approach, including geology and time as parameters. It must be used to understand the opportunities and challenges the subsurface brings to cities. So which instruments do we use to visualize and analyze 3D? Well, we have BIM, we have GIS, and the technology to visualize underground space is already widely available. However, having the technology alone available is not enough. We really need to develop a new methodology when planning the underground space. And actually, we can think about using airspace as an example. Because airspace, the aviation industry, thinks in volumes. The airspace industry blocks volumes of space and allocates them to certain functions. So I want to ask, is that a concept which could serve as a basis for a new methodology for underground space planning? How do we deal with data? We love data, don't we? And we need tons of data with what we are setting out to do. Data on geology, on soil composition, necessary to plan and construct underground. We also need data on the cultural heritage, the subsurface houses, archives, archaeology. And we, of course, want to map and visualize existing but also future planned projects. So data needs to be acquired, stored digitally, and made available by combining it in 3D models to support urban planning. Im Schweizer Untergrund das Chaos. This is actually a headline I saw in a paper last summer, where the Swiss government is planning a reliable documentation of pipes and cables in the underground. Apparently it's over 500,000 kilometer network. And Swiss Topo's answer was, it is time to produce knowledge. What have we buried in the subsurface? How can we use this knowledge to our advantage and plan for a better and resilient subsurface of our cities? Other countries are doing that as well. For instance, the UK with its National Underground Assets Register, where they have to depict 1.5 million kilometers of underground services, keeping their country supplied with water, gas, and electricity, but all run by different companies and owners. So how do you make sense of all that? How do you keep an overview of all that? So also Singapore is embarked on a big mission in that sense. The digital underground project between the Singapore Land Authority and the Singapore ETHZ, because one realizes that the underground is so essential for the planning, administration, and development of its future underground space. So the need for data, there's also the ASK platform, Accessing Subsurface Knowledge, which is a collaboration between the British Geological Survey and Glasgow City Council. And it's really to present all available and future data in urban 3D models. Because a poor understanding of the subsurface is considered a key cause of project delays as well as overspending. The acquisition of data is by no means easy, and I don't need to tell you because you're all part of this industry. But lacking knowledge of the ground conditions are main reasons for time and cost delays, and due to a lack of regulations for private developers, geologists struggle to develop the models. There's no standard format, it comes at a high cost, the lack of harmonization and information, obstacles to creating 3D models. And of course, the devil is in the detail. Increase of the data that needs to be stored and processed. But what are the urban planners' needs in all this? Current concepts are very much driven by the needs of geologists and engineers. And urban planners need access to information without the need of specific expertise and know-how in underground construction. So they need simple and user-friendly models. This is an example of the Deep City project proposed by EPFL, which is really a decision framework based on the resources to need paradigm. It considers resource potentials prior to specific urban projects and plans, and has set out to use mapping as central to the project, using available data, transforming it into maps, and illustrating citywide opportunities. And it considers really the need for urban planners, engineers, and geologists. And that's really where we need to get to in the future. Use of various data sources. I have here what we use at Amberg Engineering. So we have topographic data. We have GIS, we have geology. We have existing models. We have seismic models. And we have scan data. We produce multi-source insights out of that. We can really work with this information for our clients and partners and showcase what we're trying to build and where. And we can produce geo-insights. Till now, geology was conveyed with explicit methods based on borehole data, and advanced explorations were produced as drawings. We're now creating models with much better predictive accuracy. So all new findings are evaluated in real time and are immediately available to those involved as a model. We're even going beyond BIM. We're calling it geology interdependent scheduling. So for instance, if we talk about tunneling, the advance rate depends largely on the excavation method and the geology, but the speed depends on both parameters and both influence each other. And in heterogeneous environments, like the subsurface in difficult soil conditions, alternatives are very difficult to assess. But in our approach, geology impacts the time schedule and evaluates all available data. And that makes us all more in one, talking on the same length and being on the same page. A very quick word on contemporary thinking on urban underground space and how do we want to extend our urban centers in the future. Well, we want to densify the city without using up land. We want basically open air underground space. So how can we achieve this? This is, for instance, a design proposed by Dominique Perrault for Paris, but this can be anywhere. A pedestrian passage close to the surface with natural light. Multi-use functions and features. Public transport meets public space, meets shopping, meets entertainment and art, meets parking, and is all powered by geothermal energy. So how do you like that? The thing is, we need to have a very clear understanding of what we're already housing in the subsurface and what we want to house there in the future to make such concepts work. And in conclusion, I want to say the future is out there, and a large part of that future is still below the surface. The underground space offers as yet untapped potentials, but our job is to unveil what is hidden and visualize and map it. Then we can use it for smart and sustainable city development. We can create connectivity and we can combine uses. And we're freeing up surface space at the same time, maintaining the livability of our cities. We can balance urban development above, at, and below the surface. And we can visualize all that in 3D. And that will make major steps in unveiling the city below the city. And with that, I thank you very much, and I'm open to questions and comments.
Thank you, Antonia. Thank you very much for this very nice presentation. I check if I have some written questions. In between, I have a question.
Yeah.
Basically, I'm a surveyor, and I'm very sensitive to the legal aspect. So you told us the technology is ready to make a documentation on 3D cadastre or 3D to see the world in 3D. But what about the legal aspect? What do you think about this this important aspect of the presentation and of the regulation of the underground?
Very tricky question, Maurice. You're right. That is a big point, and it's who owns the underground, who owns the assets that are buried underground, and are they maybe confidential or need to be protected? So most cities deal with it that they now have open access databases, the city of Zurich being one, as far as I understand, and we will hear that from Gary, I'm sure, or one of the other panelists. But I know that from other cities we're doing work in, for instance, Oslo or Stockholm, where certain infrastructure is classified. And this is very much also the case in Singapore. So there needs to be a balance struck between what can be public knowledge and what can't.
Yes, I agree. This is a very tricky question, and the answer is not really easy. I know.